Hello, I am Joe Casey, the creator of Anodes: A New World. How can real-world concepts and references be used in game design to suggest a new paradigm society in a post-climate crisis world? The meaning of this question is to explore how using real-world understanding, such as the climate crisis, an Earth-based environment, and human-made maps, can aid development of an open-world, driving exploration game. I first began by creating my design pillars. Using a theme-driven design provides a set of values you can check yourself against or a source of inspiration when you're at a loss. For Anodes: A New World, these are exploring a new world, rediscovering what was lost, repairing the broken, and playful and childlike with undertones of desperation and destruction. One of my first major tasks was to create a day-night cycle which would function inside the open world. This was to ground the game in an Earth-like habitat for the player. The cycle would also add variety to the environment, causing the world, lighting, and shadows to look different throughout gameplay. This utilized Unreal Engine's Sun Position Calculator plugin and the new Unreal Engine 5 atmosphere system, instead of the older Skysphere blueprint method. I added in stars for a more appealing night aesthetic, and a moon, as the default was just a simplistic white circle, and I wanted this to mirror the real world more closely. The robot started as a simple box with track wheels. I discovered a procedural effect tool in Maya called Mash. This allowed me to create a more complex track wheel. While using this tool, I noticed that one of the parameters allowed me to offset the track, moving them seamlessly around a spline. This would prove useful for animating the track wheels. I successfully created a looping animation from using the Mash modifier. I then experimented with different versions, iterating upon the robot design. I concluded that a more detailed track wheel wasn't going to be necessary, as it would be moving too fast to notice most of the time. It would save performance if I used a lower poly design. For the texture, I wanted the body of the robot to contrast the wheels, and as the player would be racing around a desert-like environment, there would be some scuffing from general wear and tear. The eyes were initially circular, which made the character look goofy. However, after a while, it became more creepy than lovable or quirky. I changed the design to more of a rounded box shape, as if the character were wearing thick-rimmed squared glasses. This gave a quirkier appeal, which was confirmed through general feedback from peers, friends, and family. I then expanded this idea to give the robot more emotive responses, such as happy, angry, tired, or sad. This would be useful to convey emotion, as the robot is a silent protagonist and an ideal mascot for the game. The bulk of initial development was creating the drivable character. I wanted the character to have physics applied, so when they moved over terrain, the collision would react appropriately. This proved quite difficult in development, as many bugs would occur, such as having too much friction on the ground, or problems with moving on an incline or decline, due to box-shaped collision constantly colliding with the floor. After adjusting the collision, and including capsule-shaped collisions for the track wheels, movement improved, but the robot would still wobble on declines. To solve this, I created a simulated downforce which would be applied to the character on declines or when going at faster speeds. With the character driving in a much smoother way, I added camera lag, increased the camera length from the robot, and increased the FOV while boosting. This gives the illusion of traveling at much faster speeds and makes the gameplay feel faster by putting emphasis on speed for the players. Additionally, I made the turn speed more responsive by increasing the turn speed while boosting. This makes traveling at greater speeds easier by allowing the players to make faster changes in their movement direction. This is in contrast to traveling at slower speeds, as the character will feel different depending on if they are boosting or not. It is the relationship between parameters that define the feel of any system. This is what makes a game feel the way it does. Through research into causes of the climate crisis, although there are extensive reasons, 6 stood out to me. These are the world's dependence on fossil fuels, deforestation, reducing the amount of carbon dioxide being naturally removed from the atmosphere, global waste, such as plastics and pollution of our oceans and lands, manufacturing and transporting industrial and agricultural goods, land use being changed, such as converting natural ecosystems into farmland or being urbanized, and a vast reduction in biodiversity due to wildlife extinction. These causes collectively could result in humanity's own extinction if actions aren't taken to protect our habitat. Yet, I believe that in the long run, the Earth will be able to heal itself from mankind's pollution, as it has done already over billions of years and one extinction event after another. However, it would likely mean that humanity wouldn't survive to see it, but perhaps our AI creations may still be. This is the premise of Anodes: A New World. Through collecting data of the old world, the players can learn about these causes. The aim of this game is to enlighten, empower, and encourage the player. This means enlightening them of the climate crisis, empowering them through exploring and uncovering the truth themselves, and encouraging the player to help those and the world around them. This is based on tikkun olam, a concept in Judaism which means to repair and improve the world around you. While researching what would be interesting for a race course time trial, I came across two courses with somewhat simplistic designs, yet their twists and turns would help keep the player engaged due to them being more complex than a basic line or circular design. Using these tested track designs as reference, I sculpted them into the landscape terrain, allowing me to concentrate on programming in the time trial timer, checkpoints, and medal system. The world layout itself is inspired by my home city of Coventry. The circular design of the ring road system was an ideal hub location and allows easy traversal to different sections of the map. The Königsberg Bridge problem asks if a location can be traversed in a single trip without doubling back. Coventry's circular layout was a practical solution to this problem, ensuring that players would have myriad methods of navigating the environment without having to rely on just one route, as all roads would lead back to the hub location. I created a map which allowed me to plan where all collectibles, quests, and puzzles would be in the full open world. Yet, as to account for development time, I divided this into a third, reducing the scope to a more viable size. To add variety to gameplay, I developed a simple hack puzzle system. This is based on a memory test in which the user must remember the pattern sequence. This tests the brain's ability to temporarily store and use information called working memory. A human's ability to remember longer sequences is surprisingly limited, so much so that chimps have a greater working memory capacity to humans. To enable this, I created a grid of 9 buttons which get added to an array upon creation. A specified number of buttons, in this case 3 to keep the puzzle from being too complex, gets chosen at random. This means that the puzzle would be generated differently each time. When the player presses a button, it gets checked against the array, and if false, the button turns a red color. If correct, it turns green. The simplistic nature of this design meant that no tutorial was necessary to teach the player, as they can understand it through trial and error. Learning by doing is generally more efficient than learning by reading a tutorial text, because when you accomplish a task, it requires a deeper level of processing and working memory. The difficulty is also scalable, as increasing the sequence number exponentially increases the challenge. Coming to the end of the project, I have used a feedback questionnaire to better understand if players have been enlightened, empowered, or encouraged. Looking at the data, 8 of the 11 strongly agreed that they felt informed of the climate crisis. Over half agreed that they felt powerful, yet only 2 agreed that they felt encouraged, and the rest were neutral or disagreed. This shows this area requires further development, yet the data also shows that 2 of the 3 that said they didn't feel informed prior to playing were the 2 who agreed to feeling encouraged, indicating this is encouraging to players who feel uninformed prior to playing. So, how can real-world concepts and references be used in game design to suggest a new paradigm of society in a post-climate crisis world? The player can be informed through exploration of an Earth-like environment by collecting real-world items. They can be empowered through competing in time trials based on real, motivating circuits, yet more development is required to fulfill the Tikkun Olam concept, which should encourage players to help the world around them. This can be done through more specific quests to help the Anode robots and show how helping just one mission at a time can make the world a better place. I would like to thank my peers and testers for helping me improve my game. Jeff Howard and Matty Magori for their support, feedback, and inspiration on this module. Additional thanks to Andrew Crystal, Matt Osmond, Giovanni Rubino, and Matty for prior modules, which enabled me to improve my knowledge and understanding of indie game development. Thank you.